Okay, here are some limit examples that I thought I'd do for you guys to look over. Some indeterminate form that we discussed in lecture. So let's do this example here. And I'm going to try, let me see here. Okay. I think we have the limit. X goes to -1. X plus 1 over x cubed plus 1. And so here's what we talked about. If we try to use the direct substitution principle, remember this is your function. And by direct sub, this is f of -1 here. So if we recall, we're going to try to plug in this value here as an input. And when we do, since this is our function, right, x plus 1 over x cubed plus 1, notice when we do, here's what we get. -1 plus 1 over -1 cubed plus 1. And using arithmetic, this is going to be 0 over 0. Because down here, -1 cubed is -1. So we get 0 over 0. Now, this means that this is indeterminate. Can't determine by this method. And as we've seen, what you do now is you use algebra. So it looks like we're a little too close there. Okay, we're going to use some algebra. Now you might say, what algebra can I use in this function? Well, if you take a closer look, okay, the denominator here, by using algebra, x cubed plus 1, this could be factored. So yes, beginning algebra is used in calculus. So you're going to factor x cubed plus 1. That's the sum of perfect cubes here, right? So 1 cubed is 1. So you have x plus 1 over x plus 1, x squared minus x plus 1. And this is factored now. X is going to -1. So ladies and gentlemen, as you can see here, we get to cancel this. And so this gives us the limit, x goes to -1, 1 over x squared minus x plus 1. Okay. So now, this function, we talked about last time, this is like that g function, right? So remember the statement we work with, if f of x equals g of x, right? Except for maybe at a point, then the limits are the same. So we're going to note that. We're going to note that statement. Yeah, let me get it out here. I don't know, something like this, right? So if f of x equals g of x, really for all x, but, for not at a point, then the limit of f is the limit of g, and this is as x goes to a. Okay, so all they're saying is except at a point, and in this case, this is the a value they're saying, -1, but now by direct sub here, we can say this is that g, this is g of -1, this is the idea, by direct sub, we're going to have to find out what that value is, plug in -1 now for g here, because that's equal to the limit for f. So this is my limit. Let's plug in. So we're going to say 1 over -1 squared minus -1 plus 1, which is 1 over 1 plus 1 plus another 1. We're just doing order of operation here, right? 1 squared is positive 1, minus the minus is positive 1. And as you guys can see, this answer is equal to, because we have equal 1/3. So, ladies and gentlemen, that means the original limit here is equal to 1/3. And all we did was use our algebra, like we said we would, and use this statement to conclude the limit is 1/3. And that's how this works, ladies and gentlemen. So this is some things I wanted to do for you guys, some more examples like I promised. And let's do some more here. We're going to look at this as the limit. H goes to 0. 3 plus h to the minus 1 power minus 3 to the minus 1 power over h. Where again, here's my function f. And this is what this equals. F of 0. So we're going to plug that in, and we're going to notice we get 3 plus 0 to the minus 1 power minus 3 to the minus 1 power over 0, which is going to be 3 to the minus 1 minus 3 to the minus 1 over 0. And we get 1/3 minus 1/3 over 0. And sure enough, ladies and gentlemen, we get 0 over 0, which is indeterminate. So it's an indeterminate form here. Then the question becomes, well, how do we handle this? Well, we say again, use algebra. So the algebra here is 3 plus h to the minus 1 power minus 3 to the minus 1, and this is over h. Here's our algebra. The definition here of 3 plus h to the minus first power is going to be, ladies and gentlemen, 3 plus h minus 1/3 over h. Now, when I say use algebra, the algebra that we're talking about now is not factoring. So not every question will enable you to factor. You know, some will, some won't. In this case, you know, you can't factor. There's nothing to factor, really. But what you have here instead, the algebra they're talking about, you can subtract. You're going to use algebra. And so how you subtract here is to cross multiply. And just so you guys recall here, here's what I'm going to use. Just as kind of a shortcut. You don't always use the shortcut, but you know, if you have a over b, really plus or minus c over d, that's going to be equivalent to the cross multiplication, meaning AD times BC. So we get plus or minus BC, everything over BD. So this is what we mean by a shortcut for adding or subtracting unlike fractions. And that's what we're going to do here. And so my numerator now becomes 3 minus 3 plus h over 3 plus h times 3. So here's my cross multiplication. And don't forget, we have to divide by h. And what this gives you is 3 minus h over 3 times. I'm just going to commute this, and I'm going to write the definition of what we're doing here, meaning this is division by a number, a whole number. This means division, so you guys know. Let's get red. I was trying to get red there. This means to divide, and you say, what do I divide by? By h. So I'm writing divide by h. Okay, so that's kind of, you went from a vertical definition of division to multiplication. And in the numerator, though, you might say, should we simplify this? And I'll say, of course we should. So you end up with negative h over 3. 3 plus h. Now remember what it means to divide by a whole number. It's multiplying by the reciprocal. And you get to cancel. So we end up here with negative 1 over 3 times 3 plus h. Okay, so now this is that g function in the statement here. And so, we know that the limit of f is the same as the limit of g. So we're going to take this limit here as h goes to 0. This is h. Let's go back to blue. Now I'm going to put the negative sign up here. Doesn't matter. And you can say, can I use direct sub here? And I'll say, yeah, look at g of 0 now. This is again by direct substitution. And then g of 0 now, sorry for my squeaky voice, negative 1, 3 plus 0 gives us negative 1 over 3 times 3, which is negative 1/9. And, here is another question that illustrates the fact of direct substitution and using this note, but we're solving a limit question that was originally indeterminate. Indeterminate means we can't determine by this approach. 0 over 0. It's an indeterminate form. This isn't 5 over 0. 5 over 0 is undefined. We know that. Indeterminate means can't determine by this approach. So we have to fix the situation by using some algebra and that statement. And here's another illustration of that process of using algebra for an indeterminate form here. And so let me look at some more. How about a couple of these here? How about, I'll try this. The limit, x goes to 4, x squared minus 4x over x squared minus 3x minus 4. Here's a function. So by direct sub, f of 4, and we'll see what happens. Plug in 4, you get 4 squared minus 4 times 4 over 4 squared minus 3 times 4 minus 4. Gives you 16 minus 16 over 16 minus 12 minus 4, which gives you 0 over 0 again. This is indeterminate. 0 over 0. Okay. When we have an indeterminate form, use algebra. And you might say, what can I do? Well, in this case, again, we factor. And we factor the numerator, factor the denominator. So let's make sure we factor. In the numerator, we get x squared minus 4x. All we can factor is the greatest common factor. So if I write it down, x squared minus 4x over now the x squared minus 3x minus 4 in factored form becomes x minus 4 over x 4, 1 minus plus. X minus 4 goes away. Okay, so we have to remember some algebra, how to factor. X minus 1. Now, remember, this is the limit as x goes to 4 here. And this is the g of x function, which means this is going to be equal to, now by direct sub, g of 4. So I'll put by direct sub. So let's plug this in, and we get 4 over 4 plus 1, which is really 4/5. So that's the limit of this question. It's now determined to be 4/5. I'll say it again. It's now determined. Originally, it was undetermined or indeterminate. We can now say that this is now determined. Ooh. Boy. Let's hope it's there, 4/5. Okay. That's 4/5. Ooh. Well, it's in the video. Anyway. Okay. It's in the video, ladies and gentlemen. I apologize. It's not on my notes anymore, but it's in the video. Disappeared, a little crash there. Let's proceed to another interesting example where we get to use algebra for an indeterminate form. We get 1 over x minus 1 over x squared plus x. Again, this is my function f, and we're going to use direct sub, and we end up with 1 over 0 minus 1 over 0 squared plus 0. And what this becomes, ladies and gentlemen, let me remark, 1 over 0 minus 1 over 0. Now, let me remark about this. What does this mean? Well, first of all, for the limit question, this is a does not exist. Minus here looks like another does not exist. Let me double check. We're going to have to take the limit of each one separately. So we did this, functional evaluation, direct sub, and we don't have an answer. So you go, okay, this looks like if we go to 0, yeah, this will be another does not exist possibly. Okay. Anyway, indeterminate. Don't know what this means. Can't determine. So here's what we're going to do. We're going to use algebra, as you guys have seen. So the function here is 1 over x minus 1 over x squared plus x, right? So we're going to cross multiply again, because we're going to subtract here, right? So using that statement I gave you guys earlier, x squared plus x minus x over x times x squared plus x, which is x squared over x times x squared plus x. And when we cancel, we get x over x squared plus x. So you canceled right up in here, right? And then notice in the denominator, though, in the denominator, we can factor, right? So I'm going to factor out the greatest common factor. So we end up with x over x times x plus 1, and then again, we got cancellation of this x here. So the function we end up with is 1 over x plus 1. And this is the limit as x goes to 0, just by doing the algebra. And again, this is g of x. This is that g of x function in the statement. Okay. Let's get some information back here. Okay, so let's apply direct sub g of 0, and I'll write this by direct sub. So we get 1 over 0 plus 1, 1 over 1, which is 1. And so the answer is 1 by direct sub. So the limit of f is the same as the limit of g, which means going all the way back here in this case, let's be careful, didn't like it the last time, is simply 1. Okay, here we go. Let's try another. Nothing like a Sunday morning breakfast of calculus. Here's a good question. Here's a question that shows up. So, ladies and gentlemen, and we can put a bracket here to just emphasize that what you have inside here, this is my f function, and so by direct sub, f is 0, that's what that means. Replace h, be careful here, this is about h, not x, so replace the h variable here with 0. So this gives us x plus 0 cubed minus 0 cubed over 0. I'm sorry, that's an x. We end up with x cubed minus x cubed over 0, which is 0 over 0. And here's where we're at. Let me get my red. Again, well, I think I was writing that in red. Point being, this is indeterminate, okay? And we have to use algebra. So ladies and gentlemen, we get f of 0, indeterminate, we're using algebra. And 0 over 0 indeterminate form. Okay, let's use some algebra. So you say, well, what do I use algebra on? Well, let's write down that function. X plus h to the third power minus x cubed over h. Okay, now, if you look at this and we're trying to use algebra, I want to point out to you that the only algebra you could use, you're not factoring here. Because kind of in some sense it's factored, but I guess we can do some factoring. I can see some factoring coming out in some way. It's interesting if I do that factor. Let me see if I do that. Here's what we're going to do. I'm just thinking of, I've seen, here's a way. You see this x cubed? This is what they want you to do. They want you to expand this. And you say, what does that mean? To multiply. Okay, so we're going to have to multiply here. So you might say, well, what is that? That's x plus h to the third power, by definition, is x plus h times x plus h times x plus h. And for the first two, what you're going to use is FOIL. And we end up with x squared plus 2xh plus h squared over x plus h. So now we multiply. So what I'm going to recommend is when you multiply, you're going to take this x, you're going to multiply it with all three terms. Okay, and then later, you're going to take the h, you're going to multiply it with all three terms. All right, we're going to have to multiply. We're expanding. So going back to the gray, x times x squared, you're going to get x cubed. You're going to distribute, right? All three terms. So you get 2x squared h plus xh squared. So just be careful with that. You know, you can write it that way. This is, you know, using the distributive property, we're multiplying. And now we're going to get the next term and do the same. And you say, what's here? That's going to be h times all the terms. Right? So here's what you get. Now I'm going to put them in a place here like we have h times x squared. That's x squared h. So I'm going to put that below here. Okay, there's an x squared h now. And then this x, see, I multiplied these two. And I put it below the x squared h term because we're going to have to add these. So I'm going to take the h, I'm going to multiply it with 2xh. And that's going to give me 2xh squared. And I put it below because we're going to add. And then now take the h and multiply it to h squared. And you get an h cubed. So here's how we can expand, you know, multiply these terms. And here's what we end up with. We get x cubed plus, now remember, you're adding here, 3x squared h plus 3x h squared plus h cubed. There you go. Now you say, what do I do with that? Well, that goes right up in here, okay? So all those terms, by expanding using algebra, goes up there. Then, of course, we're going to subtract this x cubed from it. So you say, is this going to be x cubed plus 3x squared h plus 3x h squared plus h cubed minus that x cubed over the h. And as you guys can see now, these two terms cancel. All right, x cubed and minus x cubed. So you're left with 3x squared h plus 3x h squared plus h cubed over h. Now you might say, what do you do with every term here? Well, there's a couple things we could do. Notice we can actually distribute the division here with h, meaning h goes into every term. This is what I'm going to say by distributing. It's division has its distributive property too. If you're going to have all these terms divided by h, you can do them all separately. That's what it means to distribute. And what happens now is just cancel. Here, one of those terms goes away, and then that's a 2 power. Just by dividing every term, right, by that h. So you get 3x squared plus 3xh plus an h squared. So remember, this is the limit here. As h goes to 0, 3x squared plus 3xh plus h squared. Okay. This is the g function, and so this becomes g of 0 here. So what you're going to do here, just to let you guys know, this is a polynomial, but in two variables. And the variables are x and h, so you guys know it's a polynomial in two variables here. We can plug in, and this is, again, this is for the h. You say, what is this? This is h. H is 0, not x, right? So when h is 0, we get, notice this. This is the only place that we put 0. Here and here, the only places. And so what you really have would be 3x squared plus 3x times 0 plus 0 squared, where, you know, these portions are 0, this is 0, and we end up with a nice 3x squared. Okay? So I want to remark about this particular limit. This is a special kind of example where it's not a numerical value, but it's actually a function. And we're going to see a lot more of these in our future. So I wanted to throw that in for you guys now. I'm not sure if it's in your book. It's in my notes, though, as examples to kind of consider. But, you know, this is kind of where we're headed in our future. And probably in a couple of sections, you know, we're going to be headed here. This is a very important limit question. But I wanted to throw that in and show you how to simply go about everything that you're doing with every detail. And again, the key is using some algebra and functional evaluation. Keep track of the details, and you're going to be good to go. So anyway, here's a kind of a nice example this morning. And then I'm going to give you another kind of example here. This is an interesting example too. So we're looking at all these different interesting examples on a nice Sunday morning. Hopefully doing some homework here, right? So I have the limit, h goes to 0. I'm sorry. We go back to x. X goes to 2. Square root 4x plus 1 minus 3 over x minus 2. Here's an interesting example. So remember, here's my function f. F of 2. F of 2. Okay. So what we'll do, by functional evaluation, direct substitution, we replace here, go back. Remember, x is going to 2, so wherever there's an x, we replace it with a 2. So 4 times 2 plus 1 minus 3 over 2 minus 2. Now, under this radical, 4 plus 2, 8 plus 1 is 9. So you got the square root of 9. Square root of 9 minus 3 over 0. And remember, this is going to be a nice 3. So you got 3 minus 3 over 0. And you end up with 0 over 0, which is an indeterminate form. It's indeterminate form. Okay, so if it's indeterminate, the idea is to use algebra. So you get to use some algebra. All right. Well, using algebra, you might say, what do I use algebra on? Well, I'll go back to the original function here. Go back to f. You have square root 4x plus 1 minus 3 over x minus 2 now. And I'm going to move this over here to my left because it's going to be interesting. And here you go. So now you might say, well, what do we do? I can't factor. I can't expand. It's not really subtracting rationals like every other example we did doesn't apply here. So when you say, what algebra do I use? And I'm going to say, pay close attention here that you have a radical here. Here's the key. You have a radical. Now, I know in intermediate algebra, there's a concept known as rationalize the denominator, meaning get rid of the radical in the denominator. And then in, pre-calculus, you have rationalize the numerator. And that's what you're going to do, right? Rationalizing that numerator, you might say, well, what's the numerator? Everything on top. And how you do that is to multiply top and bottom, if you guys remember, by the conjugate. So this is plus 3. And that's 4x plus 1. 4x plus 1. So you're going to multiply both the top and the bottom by the conjugate. And the conjugate, ladies and gentlemen, this is how we do this, right? I'm going to get rid of that. If you remember, you're multiplying fractions here. And how you multiply fractions is horizontally across. So we're going to multiply this way. And then this way. Let me show you what I mean by that. Now, when you multiply conjugates, these are irrational conjugates, right? Put that word. Simply, the radicals for the first term in FOIL, you're going to multiply FOIL. The radicals go away. So you're going to have 4x plus 1, the first terms. Your O and I terms go away, because this is minus, this is plus. So you don't even have an O and I term in FOIL. You just have a first term and a last term. And the last term is negative 3 times positive 3, which is negative 9 over x minus 2. So this is what happens when we rationalize the numerator, the term on top. This is the algebra they're referring to. So whenever you have this situation with a radical, right, it's indeterminate. We already found that out. Rationalize the numerator or the denominator. It depends on where the radical's at. And that's the algebra they want you to do. And so you end up with the following. 4x minus 8 over x minus 2. And that's a division question, but you can factor the 4 out of the numerator and you get x minus 2 over x minus 2. Sure enough, you have cancellation and you just have this constant 4. So this is going to be the limit now as x goes to 2 of the constant 4 now. Because this is canceled and you just have the constant 4. You just have that 4. And the limit of a constant, again, is the constant. So this equals 4. So sure enough, ladies and gentlemen, doing the algebra gives you a very nice, cancellation question. So this limit's 4. And, these questions are all specially chosen so that they work out algebraically. Okay, so don't just write anything arbitrarily down and think you can answer that question by using algebra. There's very specially chosen questions. So here's some examples I went over this morning here for you guys using algebra. And then let's go look at some of the other examples that we've seen or introduced. The ones that have, for example, absolute value. So I'm going to have the limit here as x goes to negative 2 minus the absolute value of x over 2 plus x. So here's my function. So what's going to happen with this is, remember, x goes to negative 2. So wherever there's an x, replace it with a negative 2. When you go, what does that mean? We get 2 minus the absolute value of negative 2 over 2 plus negative 2 by direct sub, right? So notice the absolute value here of a negative 2 is positive 2. So you get 2 minus 2 over, really, addition of a negative is also 2 minus 2. And you end up with 0 over 0. This again is indeterminate. Indeterminate. Now, here's what I remarked last time. You might say, hey, Mr. Judge, do I use some algebra here? And I'll tell you, in a sense, you're using algebra. But you notice you can't factor, you can't expand. The only thing you can do here is use the definition of absolute value. So we're going to use here, the algebra we're talking about now is you're going to use that definition of absolute value. So this is going to be very handy. I'm going to say to you, the absolute value of x, remember this definition here. It's a piecewise definition. It's x if my x value is greater than or equal to 0, and it's opposite x if the x value is less than 0. Because what this means here, to be greater than or equal to 0, simply means you are positive or 0. Down here, what does it mean for x to be less than 0? That means x is negative. Okay, so this means x generally is positive, generally, because you have equal to 0. And over here, that means your x value is negative, just to let you guys know. Because any number to the left of 0 is negative. Any number to the right of 0 is positive. So you're going to use this definition of absolute value. This is what's happening for us. Okay, now let's look at the details, right? The devil's in the details. We have to know this function f is defined to be 2 minus the absolute value of x over 2 plus x. And this limit, go back to the limit, x is approaching negative 2 now. Now, since x is approaching negative 2, x is around negative 2. And if x is around negative 2, since we don't know the direction, this is independent of direction, meaning they're not telling me left. It's not a left-handed limit or a right-handed limit. You guys okay with that? Here's what I mean by that. You know, x is around negative 2. So if x is around negative 2, as we approach from the right and as we approach from the left, here's what I want you guys to notice. X will be negative. Because as you approach negative 2, this is the limit. You know, you're around negative 2 from both the left side and the right side, and you get closer and closer to negative 2. That means you're negative as an x value. And you say, well, what do I do then? You're going to use then negative x for the absolute value. Okay, because you're going around negative 2, going around that, you're going to have to use the negative value. So I'm going to say here, replace the absolute value with this negative x because you're around that value. That's what you use when x is negative. So as you get closer and closer to negative 2, you're just simply talking about negative numbers. What that means is you get 2 minus a negative x over 2 plus x. And algebraically speaking now, you get 2 plus x over 2 plus x, which is really 1. And you say, oh, does that mean the limit as x goes to -2 of that function is really the limit of a constant? Is our g function constant? And the answer is yes. You guys know what the limit of a constant is. It's actually 1. It's the constant. So this is how we handle, an absolute value question of such. It's an interesting absolute value question. But, I want to go back and use something like that to show that to you guys. And then, by the way, let's look at another one. Here's an interesting absolute value question. Limit as x goes to 0 now from the right. See if you can compare and contrast. Here again, the f function is what you see here. And what you're gonna find out in this section, I guess, here's an interesting idea. You're going to find out now, as we apply this limit and we try to use functional evaluation, right? Direct sub, f is 0. If you say, okay, what's this over 0 minus 1 over 0 again? Be careful with this. This is functional evaluation, but if you take the limits here, you're going to get something that looks like this. Taking the limits, meaning, let me go back. Let's give you the details. This doesn't kind of make any sense to us. You got like a does not exist minus a does not exist. What I want to remark is use this instead. Here's how you want to think about this. And I should have told you this for the first example. The limit as x goes to 0 from the right, use the difference property. And x goes to 0 from the right, this limit is infinity. Okay, so let me get my eraser. So we have a limit here. This first limit, I'll put it in gray. This limit here is infinity. Oh, we can't even hear Buzz Lightyear. What is it, Buzz Lightyear?
To infinity and beyond.
Okay, let's lower you, Buzz. Look at this limit here. This limit is also going to be what?
To infinity and beyond.
Yeah, there's some detail here, ladies and gentlemen. Infinity minus infinity. We have some detail we can go into. You might say, I don't know why that's 0. I mean, infinity as a limit question, but I'm going to just say this is indeterminate, okay? And we're going to discover in this section that another indeterminate form when we apply limits is infinity minus infinity. It's another flavor of being indeterminate. It turns out there's more than one flavor of being indeterminate. So this is infinity minus infinity. This is it's just as indeterminate as if you had 0 over 0. So I didn't go over that kind of detail, but I want to make sure you guys know about this. And then you say, Mr. Judge, how come you knew that this here is going to be the same? Well, let me show this to you here. What we can do here, and you say, I know I have to use algebra, right? What I'm going to say to you guys before we even go there, what you want to consider is, once again, you just simply have the absolute value function. And the absolute value is a piecewise function. Okay? You already know, we wrote the definition down a few times. The absolute value of x is x if x is greater than or equal to 0 and its opposite x, blah, 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 blah. Its opposite x if x is negative. So keep in mind, right? It's when x is negative, it's negative x. When x is positive or 0, it's x. In this case, because the absolute value is in a denominator, we got to throw out 0. 0 is not even in the domain of this function, so throw it out. Okay, so I threw out 0. Because for this function, you say, what function? For the f function, x cannot be 0. It's not in the domain. We can't divide by 0. And you said, well, I knew that here. I know. So I just want to technically show you how you look at this function, meaning f of x, which is 1 over x, minus 1 over the absolute value of x, by definition of absolute value, is 1 over x minus 1 over opposite x. You say, where did you get this? Where'd you get that minus x? Right down here. Because x is negative. How do you know x is negative? Anybody know? If you guys are in the room, I'd say, how do you guys know x is negative? And I'd play my music. So let's pretend you're here. How do I know I replace that absolute value with minus x? How do we know this? Oh no, what is this all about? How do we know? We go with the bottom. I apologize. We don't go with that. You say, Mr. Judge, I can change the question on you guys. I can change this question. Let's put this in gray. This is a right-handed limit, not a left-handed limit. So we don't use that. I can change it. You know, those instructors, how we like to do those kind of things. It's going to be actually just x. And you say, why? Because here's the reason. Because x is going to 0 from the right, and all the values that approach 0 from the right means x is positive. So we use the top, which means the function is actually 0. That's what I wanted to show people. So as you approach 0 from the right, ladies and gentlemen, that was the limit question. It was a right-handed limit. That means we just have to look at the limit now of the function, which is the limit of the constant 0, as x goes to 0 from the right. And this is the g, by the way. Limit of a constant is a constant at 0. So if you approach from the right, the answer is 0. Okay. By the way, our note, let's call that a note instead. You said, what if I went with the other? I mean, what if the question was approaching 0 from the left, right? They gave me this. I want to approach 0 from the left. 1 over x minus 1 over the absolute value of x. Well, again, if you approach 0 from the left side, that means x is negative. These values are negative. You're approaching from 0 to the left. All those numbers are negative. And in that case, yes, we need green for the bottom, right? The absolute value gets replaced with a minus x down here. So we'll replace this with a minus x. We're going to go through the detail. There it is. So my function then is 1 over x minus 1 over minus x, which gives you 1 over x plus 1 over x is 2 over x. So this limit now, as x goes to 0, from the right, from the left, negative values of x is really 2 over x. Okay, we have to find what this limit is. What I'm going to remind people, this is the g function here. So remember this concept I said to people. I said, you have to study curves. Every BSTEM student should know. curves every B-STEM student should know. And the curve here for this function, even though you have a constant, the curve is just like 1 over x. So I would say, let's put it in black here, if you guys remember that curve. Yeah, let me bring back the information. Come on. Here's my function. It's 2 over x. This is the curve. I don't want to draw a line. Here we go. All right, let's just keep it like that. Now, remember, we're going to 0 from the left, right? Let's double check we're up to date. 0 from the left. 0 from the left, that means x is negative. Okay, 0 from the left. What happens as we go from 0 from the left side? Take a look. We approach 0 from the left side. All these values of x, which correspond to points on that curve, the y-coordinate is the limit. The y-coordinate goes to, as you guys know, negative infinity.
To infinity and beyond.
So here's our answer. This is actually negative infinity. And that's how you start to deduce the evaluation of these limits. And if we change it to going to 0 from the left, that's going to be a minus infinity situation. Okay, now we could have used some of this. Anyway, this is kind of how we look at the situation. So I went over 2 kinds of cases here. One is going to the 0 from the right. One's going to 0 from the left. And then here's another by the way, just to see if you're awake here. You know, they might say to you, by the way, here's an interesting question. What's the limit as x goes to 0? 1 over x minus 1 over absolute value of x. As you guys can probably know, this does not exist. This does not exist simply because the left-handed limit does not equal the right-handed limit. Here's the justification, because some of you guys might say, why? Don't forget this definition. The left-handed limit does not equal the right-handed limit of that function. And because it's not equal, irregardless of the approach, either left or right, this is independent of the approach statement. Since it's not the same, we say does not exist. So I want to give you that little detail. It's kind of interesting. So working with these absolute values are very interesting. And I'm going to give you another interesting example. The last example. X goes to 2. X squared plus x minus 6 over the absolute value of x minus 2. Now, again, you say, is this my function? Okay, by direct sub, we end up getting, remember, we're going to replace now 2 wherever there's an x. So we get 2 squared plus 2 minus 6 over the absolute value of 2 minus 2, which is 4 plus 2 minus 6 over the absolute value of 0. And that gives you 0 over 0, which is indeterminate. So we can't determine. And you say, well, what do I do? Use algebra. You go, I got to use algebra. You use algebra. Only the algebra, remember what we're looking at here. You just have to use the definition of x minus 2. And you're going to have to pay attention to it. This is going to be both a left-handed limit and a right-handed limit. So I'm going to have to answer 2 questions here for the price of 1. This is a hefty question. So I got 2. The limit, x goes to 2 from the left of the function x squared plus x minus 6 over the absolute value of x minus 2. And we're going to answer the limit. X goes to 2 from the right, x squared plus x minus 6 over the absolute value of x minus 2. All right, we got 2 questions for the price of 1. And here's what I want to use, okay? If you ever have, here's what you want to use. The absolute value of anything. Here's the generalization of the piecewise function. Okay, whatever is between the absolute value sign, we use that if what's inside is greater than or equal to 0. We use opposite of that if what's inside is less than 0. And then you say, well, what's inside that absolute value? You get x minus 2. That goes here, that goes here, that goes here. So that means x minus 2 and opposite x minus 2. Put that in parentheses. This is x minus 2 as well, and this is x minus 2. So wherever there's a triangle, you replace it with x minus 2 because that's what's between the absolute value sign. So I'm going to use this format always, 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 the generalization of absolute value. So, what does that give us? The absolute value of x minus 2 becomes simply x minus 2 if x minus 2 is greater than or equal to 0, right? Piecewise, and its opposite x minus 2 when x minus 2 is less than 0. This is how we define the absolute value of x minus 2. Now, pay attention to this. When do we use the top? When x minus 2 is greater than or equal to 0. What that means, if I add 2 to both sides, that means when x is greater than or equal to 2. That's when I use the top. When do I use the bottom? Right? This opposite x minus 2. Well, pay attention down here. X minus 2 is less than 0. Add 2 to both sides. That means when x is smaller than 2. Because I'm adding 2. We got a simple linear inequality. I added 2. You guys know that there. So you have this kind of detail I want to remind people. So, in my mind, sometimes I just clarify everything. I say, okay, when do I use things? I write every step. So the absolute value of x minus 2 is going to be the top, which is x minus 2, if x is greater than or equal to 2, and its opposite x minus 2, if x is less than 2. This is the absolute value function here. Okay? That's what you guys use. You go, okay, well, what does it have to do with this particular question here? Well, this is going to help us simplify. Remember, I have 2 questions. The left, this is approaching 2 from the left. That means x is smaller than 2. And when x is smaller than 2, here's what I use. So I replace this with minus x minus 2. And you say, what about this other one, Mr. Judge? What about when x goes to 2 from the right? That means x is greater than 2. The values of x, as you approach 2 from the right, those values of x are bigger than 2. So I replace then the bottom now with just simply the top, x minus 2. Greater than 2, we replace it with this is the top here, right? And less than 2 from the left, use it with the bottom. And that's why we use the generalization formula. We can fix these here. And so let me look at these here. Remember, we're going to do this first question first. So here's the limit. Here's the question. The limit, x goes to 2 from the left, x squared plus x minus 6 over minus x minus 2. Now, I want to point out another detail. Hopefully, I wrote it down correct. So is it x squared plus x minus 6? Yes. Okay, let me point out another detail about algebra here. You guys can use algebra here. In other words, what do you mean use algebra? Factor. So you have the limit, x goes to 2 from the left, and if you factor, right, you get x, 3 and 2. This is plus 3, this is minus 2, this is minus x minus 2, because I factor the numerator. And as you guys can see, the x minus 2's go away, but you are left with that minus sign. And that gives you the limit as x goes to 2 from the left minus x plus 3. So this is the g in the statement we gave earlier and the other day. And by direct sub, we need g of 2. And you end up with, replace x with a 2. So we get minus 2 plus 3, which is negative 5. So the left-handed limit will be negative 5. That's the left-handed limit. Remember, to answer the approach of 2, irregardless of direction, we also need the right-handed limit. So you say, well, how do I get the right-handed limit now? Well, let's see. Limit as x goes to 2 now from the right, which means, again, the values of x are greater than 2, right? Larger than 2. So my function then becomes, over here, x squared plus x minus 6 simply over the x minus 2. We're looking at this over here now. This is from the right. So x squared plus x minus 6 over x minus 2. And again, you factor the numerator, right? Factor. And you'll end up with, what was that? X plus 3, x minus 2 over x minus 2. And again, you get the cancellation. So this is just going to be the limit, x goes to 2 from the right, of x plus 3. And so now by direct sub, replace this x with 2, and you get 2 plus 3, which is 5. So the right-handed limit question, oh, here we go. We're looking at, this is the right-handed limit, 5, right? And the left-handed limit, negative 5. Same thing, we could say this is g of 2. So in one case, it's negative 5. And in the other case, because this is g, it's positive 5. So they're opposites. So in conclusion, the limit as x goes to 2, irregardless of the direction of the original function, absolute value of x minus 2, does not exist. Simply because, remember, the left-handed limit is not the same. As the right-handed limit. They are not equal. Since they're not equal, final answer, limit, does not exist. Okay, ladies and gentlemen, I just want to let you guys know, I thought I'd give you guys a little bit of review of these problems. I said I would. Hopefully you guys are having a nice Sunday. You want to look over this stuff. It will be on your test. These are good limit questions. And so, have a good rest of the day. But take a look at this. The details are here. Take care.